Hey everyone, so this is number 26 from chapter 3, which is dealing with 2D motion, projectile motion. So number 26 reads, an object is launched with an initial velocity of 50 meters per second at a launch angle of 36.9 degrees above the horizontal. Make a table showing values of x, y, v sub x, v sub y, and the speed v every 1 second from time equals 0 to time equals 6. All right, so first thing, again, we'll do like we always do is write down what we know. So we know that v is going to be 50 meters per second. That's our initial speed. And we know that it is launched at 36.9 degrees. So my next thing, because it makes life easier because it is shot in 2 dimensions, is I want to know what are the x and y components. So v sub x is going to be 50 cosine of 36.9, and v sub y is going to be 50 sine of 36.9. If you do those out, you get that v sub x is going to be 40 meters per second, and v sub y is 30 meters per second. So now we can attack this chart. So we'll have a chart that has x, y, v sub x, v sub y, and v on it. And for our times of 0, 1, 2, 3, 4, 5, and 6. So v sub x at 0 is going to be 40 meters per second, and it's going to be that the whole way through. Right? Because remember that horizontal speed does not change. There is no acceleration, so we can fill this column in all the way down. 40, 40, 40, 40, 40, and 40 more. The next thing we can fill in is our x. Right? Because our speed is 40 meters per second in the x direction, that means every second it's going to travel 40 meters farther. So we start at 0. After 1, it's gone 40, 80, 120, 160, 200, and then 240. We can also then plug in that y is going to be 0, and our v sub y is going to be 30. All right, so our next step is going to be to find our y. So to find my y, I use the kinematic equation of y equals y sub o plus v sub o y t plus 1/2 g t squared. When we do that, we get y sub o is 0, v sub o y is 30 times 1, that'll be the time period we use, plus 1/2 times negative 10 times 1 squared. And when we do that, we get a distance of, we get a y that is equal to 25 meters. So we can plug that in right here. If we follow the same pattern, just changing our times from 1 to 2 to 3 to 4 to 5 to 6, we get distances of 40, 45, and then back down 40, 25, and 0. Right, you'll notice that these match up where halfway up our flight, when time is 3, we get at our peak, and then we fall for 1 second, and we go back down to 40 and 25. There's this nice symmetry that happens when we deal with these free fall events, and we can use that to our advantage sometimes. So the next thing we've got is v sub y to fill in. Remember that when we're in the y direction, our speed here, it's going to decrease by 10 meters per second every second because of gravity acting on it, right? If we remember that g is equal to 10 meters per second, this means that every second, should be negative, every second the speed is going to change by 10 meters per second. So we go from 30 down to 20 to 10 to 0. Again, right at the peak, halfway there, speed is 0. It's gone to the top and it's stopped. And now we've got negative 10, negative 20, and negative 30. So the last thing we do is we attack v. All right, so when when time is 0, v is 50. We get our 3, 4, 5 triangle. So now we just go and we Pythagorean theorem the rest of them, where if we do it for the time is 1, so our speed at 1, right, it's going to be 40 squared plus 20 squared, right? We take the square root of that and we get that it's 44.7 meters per second. So 44.7. And if we follow this pattern, right, we just change our speeds here. We've got 41.2 to 40, and then it starts to speed up again. 41.2 here, 44.7, and then back to 50 when it hits the ground. So part B asks us to make a graph, and our graph should look something like this. If we've got our y and our x, time at 0, 1, 2, 3, 4, 5, and 6. And you'll see that opposite times they line up perfectly in the y here, and then in the y direction they get a little closer, then farther apart. Same here, a little farther, and then they get closer to reach the top. And in the x, the distance between points horizontally should be the same. So that's that one. I hope you find this helpful.